Okay, so in this video I want to do 3 more proofs that are a little more challenging. They're still considered simple proofs because we're still just using the 8 rules of inference. We haven't added the rules of replacement yet and so on. But before we do that, let me show you these invalid inferences. These are mistakes, and Hurley points out a lot of these in his book, and they're worth reviewing. So if you look at number 1 over here in the top left, A or B and C, therefore B by simplification. No, this is invalid, right? You must have B and a C on a line by itself in order to simplify. And you can kind of talk it out. Let's say A is I'm eating, or I'm singing and dancing. Okay? Therefore, I'm singing? That just doesn't follow. Okay, so that is always a bad inference. You can't just focus on part of a statement and simplify it. Let's look at the next one, K, K, and L. Alright, this is invalid as well. It's like saying I'm swimming, therefore I'm swimming and eating. Okay, you just can't do that. However, I could say I'm swimming or I'm eating. You can only use addition with you can only use it with the wedge. You add something by the wedge, the or statement. So this is invalid right there. Okay. All right. So let's do the next one, A or B. You can't get A from simplification. In order to get simplification, it would have to be A and B. Because in A and B we know they're both true if the and is true. So we can say A is true and B is true by simplification. But here, A or B, right, we don't know which is true. One of them's true, we don't know which one, so we just can't simplify A to A. I'm either swimming or I'm eating. Therefore I'm swimming. That just doesn't follow from it's true that I'm swimming or eating. Okay, look at the next one. Okay, if A then B, and then we try addition, and we're just adding to part of the conditional. Well, you can't do that. If you're going to use addition, you have to add it to the whole statement. So this is what addition would look like. We have if A then B, right? Then we want to add a statement with the or J. So that's what it would look like if it were valid. But this is not, and you can talk it out like if I'm swimming then I'm happy. Number 1, if I'm swimming then I'm happy. Number 2, if I'm swimming then I'm happy or sad. Well, no, that doesn't follow from the truth of 1, right? However, if I'm swimming then I'm happy or I'm sad. Okay, that could follow because we know this disjunct is true. Okay, but let's just cross out the whole thing there. Okay, the next one we have if L then M, if L then N, and M and N by conjunction. Well, no, that doesn't work either. You have to get M and M on their own line. You have to get M by itself, and then N by itself, and then conjoin them, right? That just doesn't work. I don't know. And then if A then B, therefore A. No, that's always invalid because we're saying if I'm swimming then I'm happy, therefore I'm swimming. That just doesn't follow from the first premise, right? You can't assert the antecedent is true just because you want it to be true. Okay, so those are some common mistakes. Let's do some more proofs. All right, and let's see which one was first. I don't even remember now. Okay, yeah, let's try this one first, I believe, or was it this one? Darn it. Okay, let's just pick any one, right? Okay, it wasn't that one. I think it was this one. Okay, so we have if B or F, then if A, then G. B or F, if B or F, then if G, then K. B and not H. If A, then K is the conclusion. Alright, so you want to just start talking it out. Okay. Now, if it's a conditional that's a conclusion, maybe you can use a hypothetical syllogism somewhere. Because you see over here the conditional is a conclusion too. So if A then K, if we had if A then G and if G then K on a line by themselves, then we could get if A then K. But we don't have that right now. Okay, so notice what I'm doing. I'm talking it out, right? And this is what you want to do. We want to get B or F so we can get these on lines by themselves. and then conjoin them. How do we get B or F? Well, we can get B right here. Now, the alternative is you could just randomly start applying these rules too, right? We could use the most obvious rule is B, and this is 3, simplification. Now, let's say you don't have a clue about how to solve this. That's okay. You're groping in the dark. But when you're groping in the dark, you're using these tools over here to grope. Okay, so it's not really blind groping. Okay, so we could use the tool again to get not H from 3. Okay, not H, and that would be 3 simplification. Now I see how to solve this, but I'm trying to pretend I'm just learning and I don't see this. I'm just groping in the dark with the rules, right? Okay, but now I want to get, if I could get B or F, I could apply modus ponens. And look, I have B, and there is a rule where I can get B or F. It's addition. Okay, so let's apply that rule. So 6, we're going to do B, and we're going to get or F. And this is 4, addition. Okay. Alright, now it's coming together pretty nicely. Okay, even if you don't see it yet, just apply what you see next. You have B or F, so apply that to 1, right? And we get if A, then G. If A, then G. Oh, that's supposed to be a G. Okay, and that's 6 and 1 modus ponens. Okay, now we can also get if G, then K. Okay, if G. Okay, that's supposed to be a G, then K. And again, we got that from 2 and 6, or 6 and 2, modus ponens. And remember earlier I said we could use a hypothetical syllogism if we had these two on the, well, we don't even have to put them on the same line. We can do 9. We're going to do 7 and 8, or let's say 8 and 7. 7 and 8, I'm sorry, because you have if A then G and if G then K. If 1 then 2, if 2 then 3. Therefore if 1 then 3. Right, so we're going to do 7 and 8. Okay. 7 and 8, and that is hypothetical syllogism. My 8 looks like a 0. Okay, and that comes out to be if A then K. Alright, we've did it. We've done it. Right. And we've proven that this follows. You could have skipped step 5, but if you included it, it's just as valid as if you skipped it. Okay, we didn't really need it, right? But so you could have done it in 8 steps, okay, or maybe even in a different way. Okay, so let's close that one and go to the next one. Okay. Oh, I know I didn't. Oh, I did. Okay. All right. So the next one we have if F and M, then S or T, and so on. Now we have T. That's our conclusion. So we want to get S or T somehow. And we have all these conditionals, but I don't have any conditional antecedent to. But I do have not S and G. So I could simplify. I mean, I can get not S, right, from 4, and that would be simplification. Okay, and that's a start, right? Even if you don't see where you're going with it, go ahead and apply the rule. Simplification. Go ahead and apply the rules and see what happens. Now, why not, since we're looking for not S or A, why not just use addition on 5 to get not S or A? Okay. Remember, when you're looking, addition is often overlooked when you're doing these, but it's a nice little tool to add with the little wedge sign. So we have not S or A, and that's 5 addition. Okay. And there you go. Oh my gosh, I'm getting sloppy. Okay. Now that we have not S or A, we can get F, right? With modus ponens up above. Okay. So I'm going to write F. Okay, and that's 6 and 2. Right. modus ponens. 6, supposed to be a comma, 2, modus ponens. Excellent. Alright, so we did quite a bit. Notice if we want to get t, we have to get f and m, and then we'll get s or t, and then we could get not t maybe. No, we get not s, and we already have not s, and then we could get t. Right? So you're talking it out as you move along, looking for clues, or just blindly groping in the dark with your rules. Okay. Now, for this, I'm going to just do not s or b, and the same rule we used earlier. Okay, which is we're using 6, not s, and we're using addition. And the reason I was looking for that is because if you look at number 3, we want not s or b up here to get m. Okay, so now we have not s or b, so we can use 8 and 3 to get m. 8 and 3, and that's modus ponens, and now we have m. Oh, that's messy. Okay, so that's great. Then we combine. Now we want the first premise. So we have f and m. We just need to combine them to get that antecedent in the first premise. All right, f and m, and that's 7 and 9, and that's conjunction. Okay. And now we can use f and m on 1 to get s or t. Okay. And that is modus ponens. Okay, so that's 10 and 1. And 1. And that's modus ponens. Alright, and remember we're looking for the t. Keep the end in mind whenever you can. Okay, and we have not s and 5, and we got s or t down here. So, alright, so you should be able to see we can get t with 5 and 11. Okay, and that would be disjunctive syllogism. Okay, you can look at your rules over here if you need to. Now there may be some other steps that you could do along the way, and that's okay. Like I could just be experiment. I could put for premise 8, I could put f or a and see if that gets me anywhere, and it won't. But I could do that by addition, you know. So there's other steps that you can do, and there we go. We've solved it. So this is a valid argument. All right, let's see if we can squeeze in one more difficult one. Well, not difficult, but it's a little more challenging. Now this one is interesting because the conclusion contains letters that are not in the premises. And what that tells me is I'm going to have to use addition somewhere. Now let's say I don't even know where to start on this. Okay, let's just say I'm intimidated because I've never seen one like this before. Okay, but notice, just start looking where can you apply rules, right? We do have not q here. I believe that's correct. So we could get s, right, with disjunctive syllogism. Let's go ahead and do that. Get something, right? So not q, we would get s, and we have 2 or 3, and that's a disjunctive syllogism. Okay, and let's see what else we can get. Notice the first premise is set up really nicely for this constructive dilemma. We have s or q, and we have these two conditionals, so we can infer something from that. Okay, and this is q or not s. Okay, so we have q or not s. Okay, and q or not s, and that's 1 and 2 constructive dilemma. Look for those constructive dilemmas. Sometimes students overlook that step. So we could do okay. Let's see here. What else can we do? Can we get q anywhere? Well, yes, we can. We have s here, which is the same as not s, right? So we can do 4 and 5, disjunctive syllogism, and now we have q. Now, if we have q, we can now add the conclusion. Q or P and R. P and R. Now you should be able to solve it. Okay, I'm running out of time, but what you would do now is you also have not Q, so you can get P or R with 7 and 3 disjunctive syllogism. Thanks.